This is the process used by Polycoat Systems near Houston, Texas, to make vacuum and pressure-rated fiberglass tanks that can transport a variety of chemicals over the road safely. The process begins with a metal mold, which gives the tank its form. First, a fiberglass fabric veil is applied. This fabric is then saturated with a resin customized to the chemical the tank will carry. Workers can control the blend of resin components to optimize its curing time to the manufacturing process, and this is tested. The veil layer creates a thick lining of the resin to optimize chemical resistance. Next, a bulking layer is applied, made of long glass fibers that are drawn from a roll, then chopped and mixed into a resin stream that a worker sprays onto the tank. This layer uses the same resin as the veil and adds thickness and additional corrosion protection. A thermometer is used to monitor the progress of the curing process, a reaction which creates heat. The head of the tank is built up using woven fiberglass. Building the head directly onto the mold creates a lap seam, which is stronger than attaching a separately built head with a butt seam. The process is repeated several times to create a thick, strong surface. A box is attached to the head to assist with tank handling. A ring is attached as well to act as a stop later in the process and to create an attractive edge. 2 completed liners are removed from their molds and brought together to create a single tank liner. With the chemical-resistant liner completed, the next step is to create a strong structure. First, more chopped fibers are applied to create a bedding layer. For this particular tank, workers add a conductive layer of carbon fiber, which will enable the liner to be tested using a method called spark testing. Next, continuous glass filaments are wound around the tank to resist expansion due to pressure. Then, unidirectional fibers oriented along the length of the tank are applied in rolls and saturated with resin to resist buckling and bending. This completes the inner layers of the tank, both chemically resistant and structurally robust. Now, a polypropylene honeycomb core is added before the next winding layer to separate the structural layers. While balsa wood is sometimes used for this purpose, these hollow plastic cells provide greater chemical resistance and can deal with impacts better in the event of an accident. The core also increases the stiffness of the barrel. Although the core itself is flexible, it functions like the center of an I-beam, separating the top and bottom layers so they cannot bend without deforming the other parts of the structure. These cores allow all of Polycoat's tanks to be rated for full vacuum. With the core in place, a second winding layer is applied. The location of the outlets and rollover protection are marked and masked with tape, and a finishing compound is applied to smooth the tank's surface. This layer is sanded, and holes for the outlets are cut by hand. Rollover boxes, manways, and outlets are made in the small parts department or provided by vendors to tank specifications. Workers now install these items and build them up with fiberglass and resin so that they are integrated into the structure of the tank. Workers climb into the tank to finish and seal the outlet stubs using the same corrosion-resistant resin as the rest of the liner. A worker carefully cuts and forms a fiberglass mat to create a seamless, corrosion-resistant connection between the outlet and the tank. A veil is then added in the same way, and the final product is checked for resin cure and quality. With the fittings in place, the exterior of the tank is primed, sanded, painted, and then shipped to a vendor, which adds framing, straps, wheels, and other components to turn the tank into a finished trailer. With that, the custom tank is complete and ready to safely transport the industrial chemicals for which it was designed over highways throughout the country.